Hello. Hello. Okay. We will start today the unit 3 of part 1. Unit 3 of part 1 we have already seen. We will start today unit 3 of part 2. Part 1 in part 1 we completed the design of eccentrically loaded column yesterday that we have completed. Uh, the design. Okay. Yesterday we completed this example. Check the adequacy of the section as HB450 to carry axial compression 750 kN at a centricity of 470 mm about its major axis. So this is uniaxial bending, then only two terms here there N upon ND and Z upon DZ. And then we write down what is given in the example and the properties of the given section. Then we find out the MZ forces on the column, that is green column. Then section classification, you know the beta B value. Then design strength in compression regulating ND is equal to AGFY upon gamma M0. And then as we know the effective length, we can find out the slenderness ratio by knowing the R minimum from the sectional properties and the critical stress of the section FCRB. We have find out from the table number 14 of IS code, and then your by interpolation you can find out FCRB is 711. And based on that, we have, as you know, the value of beta B is FP. Now we have to find out FBD. By knowing the FCRB, we find out FBD by using the table number 13A, that is alpha LT. In our case is 0.21. So FCRB by interpolation we got the FBD. Based on the FCRB value, we can calculate the FBD, and FBD is 202.795. When we put all the values and we give the MDZ is equal to 396.47 km/meter, and then from the intersection equation N upon ND MZ upon MDZ you find out, and this is less than 1, as we said that the given section is capable of taking 750 kN of load with eccentricity of 270 mm. Okay, this is we have seen yesterday. This example on a eccentric column we have completed. Today we will start the part B of our part B of our unit number 3. Wait a minute. I will connect the writing pad. Forgotten to connect this. So sorry for that. So this one, unit number 3, part B. Unit number 3, part B. Okay. We take some another color so that it should be. So this is unit number 3, part B, or part 2, whatever you can say. And today is 24/9/21. The column basis, steel columns are normally supported over a concrete block because the cross-section dimension of steel is very less. If you go for the I section, the cross section dimension as compared to the concrete column, it is very less. Okay, so it requires uh, very good compression strength. But the bearing capacity, because all the columns they are rested on the concrete, because steel we cannot use as a foundation due to its disadvantage that it corrode or it attach with the sulfate and then carbon and then carbonation take place, and that will corrode the steel, and the corrosion may be strength of the steel will loss of some or few days after a few years. It may be the sectional dimension will be reduced due to this corrosion effect. So generally, the steel columns supported over the concrete block, and bearing strength of concrete block, bearing strength of concrete block is very less. Bearing strength of concrete is very less. Okay. So due to the heavy load coming on the column, steel column, what happen? It may be sink into the or there may be crushing of the pedestal or foundation below the steel column. So that's why the load is transferred from the column to the large area, and then from that large area of that plate is transferred to the concrete pedestal. So, however, when the load supported by these columns are large and the bearing pressure of concrete from below is insufficient to resist the loads, they may fail. Therefore, it is normal practice. It is normal practice uh, to distribute the column loads or to steel base plate, to distribute the column load to steel base plate, okay, which are placed over this concrete block. So to increase the bearing area, what we are doing, we are providing a base plate below the column. So this is our I section. If this is your I section, okay, this is your column, I will say. So we are providing the steel base plate below the I section, so the load can be transferred to the large area. Okay, and still having a yani property that its bearing strength is large and very less thickness is required. So that's why we are uh, below the column this base plate is provided so that the bearing area will increase. So this is your base plate, and these base plates are called as column bases, or called as column bases. So this is the column, and below that the base plate is there, and this is called as the column bases. The purpose of column base is to mainly transfer the column load to the foundation, which in turn transfer the load to the soil. Okay, so you know that this is your column, this is your column, okay, this is your column, okay. So this it may be I section, channel section, whatever you are using. Okay, this is your column. So below column you are providing the base plate with the fillet angle. This is the fillet angle. Okay. And below that we are providing the foundation. Okay, the foundation. Okay, concrete foundation. So we are showing the concrete like this. Okay, so this is the concrete foundation. So this one is nothing but your column, steel column, and then from your steel column, and from your steel column, the load is transferred to the base plate. This is called as column base, or it is provided in the slab base, and this is your concrete pedestal or concrete foundation. Concrete foundation. Okay, so this is the, and below that concrete foundation there is a soil. Okay, that is ground. Here load is transferred to the concrete foundation to the soil. As the transfer of load is from the steel column to the steel base plate, at the transfer of the column, as the transfer of load is from the steel column to the steel base plate resting on the concrete block, the base plate requires a large area to distribute the load on the weaker concrete block. Okay, so that the area is increased by providing the base plate to the below the column. Okay. The same is the phenomenon in the concrete block transfer the load to the soil. Thus, as the load is transferred from the column to the base plate and the base plate to concrete block, the plant area requirement of the base plate and the concrete block depend on the bearing strength of concrete and soil respectively. Okay, so it depends on the bearing area of the concrete below the base plate. Okay, definitely. Now we'll see the types of column bases. Earlier, when we are going for the practical sheet number 4, where also we have seen the different types of column bases. So there are generally following types of bases are provided for connecting the column to the base plate. First one is the slab base. Slab base is for the carrying for axial load or light load or axial load only. Gusseted base are provided for medium load or heavy load and moderate movement, moderate movement. And moment resistance base are provided if there is bending moment or moment, large moment are there on the column. So these are three types of bases you can provide, and these are the column bases. The column bases for carrying axial load and for carrying axial load and moment. So this axial load and moment is generally taken by the moment resisting base. Okay, so to resist the moment, bending moment and the axial load, you are going for the moment resisting base. Okay, so slab bases for the light load up to, it is larger, it is given there up to 1200 kilonewton. Uh, if you go and for medium load, slab base exceeds uh, thickness of the slab base exceeded 50 mm, then we are going for this gusseted, gusseted base. Okay, so these two types of bases we will see. So already, if you come to your practical online practical class, sorry. So here we are seeing the different types of bases. Here we are seeing the different types of bases. So if slab base is there, you can say see here only the base plate is there, only the base plate is there, and with the base plate transfer the load to the column. So here this is your column. You can see this is your column. This is your fleet angle to support the to hold the column in the position. That is the fleet angle, and this is your base plate, base plate, and this is called as, this is simply, if there is no other gusseted material is there, then this is simply, it is called as slab base, and this is designed for the axial load only. Axial load only. If the column is only the axial load is there, then we are going for this. Okay. So this is the web plate. This is the web plate. You can see in the figure. So these are the slab base. Okay. Similarly, different figures are there, and for the slab base, you can search on the internet also. I will go through shortly. This is the gusseted base, the second type of column. Why this is called as gusseted base? Because if the thickness of slab base is required large, if the thickness of slab base is required large or more than 50 mm as we have seen earlier, so in that case we are going for the gusseted base. What we are doing here, we are using the gusset material. Gusset material means this is your column, this is your column, okay, this is your column. In addition to this column, we are providing the gusset material. You see this is the gusset material. This plate is attached with the column is called as gusset plate. Called as gusset plate, and this gusset plate is attached with the angle. This is called as gusset angle. Okay, so these are the area of this column is increased. The area of this column, bearing area of this column is increased by using the gusseted material. The gusset material, this is your column, okay, column. This is your gusset plate, and this one is your gusset angle, gusset angle. Okay, so this is making the column with a large area. You can see in the plan also. This is the gusseted material attached with the flange of your column. Okay, and these two you are saying is the nothing but they are web cleat. They are web cleat. Okay, so that why this is going for the gusseted base, because the load is heavy and if there is moderate moment, then we are going for the gusseted base. So you understand that the difference between the gusseted base and the slab base is that the gusseted base is with the gusset material, and slab base is only the base plate below the column. Okay, but in gusseted base, the column is with the additional plates, and that are called as gusseted material, or that is consist of gusset plate and gusset angle. Now the third type of your base plate is the moment resisting base plate. When the base plates are loaded eccentrically, when the base plate are loaded eccentrically or subjected to axial load as well as bending moment, subjected to axial load as well as bending moment. So you can see if the base plate is with a centrically load, axial load is there, and centrically load is there, definitely there is load PU and MU, that is moment also acting, and that is nothing but PU into E. E is the, it is eccentricity. So due to eccentricity of loading, there is moment and is behaving like a moment. So the pressure distribution from the concrete does not remain uniform. Therefore, it is not uniform. The pressure distribution. So an axial load causes compression between the base plate and the supporting concrete pedestal, while amount increases the compression on one side. So one side the compression will increase, and the compression stress is maximum near one edges of the base plate and decreases toward the another edge. So you can see here there is the differences. So stress distribution is equal if there is axial load. If there is bending moment, the stress distribution is like that. If there is combined axial and bending moment is there, then stress distribution of the base plate will be like that. Okay, so combined stress for no tension, if no tension, then there is the stress distribution is like that. So we have to design if there is bending moment also coming on the base plate. So design of moment resisting bases are come into the picture if there is axial load and bending moment combinedly acting on the base plate. So that is called as moment resisting base. And how to design that, which is also given here, and how to find out the moment and all the steps to find out the stresses, centricity, and here is three cases for design of the moment resistive base: when there is no tension, when the tension develop is small, and when the tension develop is substantial. So these three conditions are there, and for these three conditions or three cases, we will design the column if there is shell load with the bending moment. Okay, so this one is nothing but design of moment resisting base. Design of moment resisting base. Okay, so now today we have seen three types of bases: Gusseted base, slab base, and column with the moment, that is moment resisting bases. So three types of bases are mainly there: slab base, Gusseted base, and moment resisting base. Okay, so these are the three types of column bases we will design in coming lecture. Now we will see the slab base. Okay, so slab base, we know that slab base, the load is directly transferred from column to the base plate. When the base plate is provided, this is used for column carrying either axial load or axial load with moderate bending moment, variability, so that the pressure distribution is wholly compressed. The pressure distribution in the slab base should be wholly compressive in nature. Usually the actual base plate area is more than that required for bearing, and the effective area of the base plate is found by considering the shaded area of the shown below for various cross sections. So this, if you get see in our AS code, this shaded area is nothing but effective area. These are the, if I will dark this, so these are the effective area. Only it experience more stresses due to column load. But we are providing the large area. This outer area, you can say, this much area we are providing. Uh, but effective area is only the shaded area. It is nothing but from the center. It is two times. It is two times C plus two times C plus T. Okay, T is the thickness. Here, when there is a hollow tube is there, here also this is the effective area of the tube. This is the hollow tube. This is the hollow tube. Okay, this is the hollow tube. This one is the hollow tube, and you can see this shaded portion. Shaded portion is nothing but uh, shaded portion is nothing but the effective area. Okay, so this is the shaded portion. Okay, because of hollow, so its center also it is not effective, and around is also not effective. Y section is there, so this is the shaded area. Okay, the wave and flame is there, so at the wave and flame there is the effective area for I section, so that's why always the effective area is less than the size of base plate in case of slab base. Okay, now we will see all these things. Now we will how to find out the area required in case of base plate. The column load we know, based on the column load divided by the bearing pressure or bearing strength of your concrete. We know that in limit state method, in LSM, the bearing strength of concrete is 0.44 uh, 447 FCK. Okay, or you can write down approximately it is 0.45 FCK. So only 45% is still considered in LSM. In WSM, uh, uh, the FCK we are considering in WSM, the bearing strength we are considering 0.6 times of FCK. But because our design is fully based on the LSM, so we are going for this only. So we are going for the limited state method. So in LSM, if for M20 grade, if you find out the bearing pressure, so for M20 grade, for M20 grade, in 20 grade, the FCK will be 20 Newton per mm square. 20 Newton per mm square at 28 days. At 28 days strength. Okay. So FCK, you know the characteristic strength of concrete. Okay, based on the grade of your concrete. So for bearing strength, अगर हम मालूम करेंगे bearing strength of M20 concrete, it is nothing but 0.45 FCK. 0.45 FCK. If you write down 0.45 into FCK is 20, so it is coming something 9 Newton per mm square. So it is very less. So you can say the bearing pressure on the concrete is very less as compared to the steel. So that's why we are going for the slab basis. Now, upward pressure on the plate, calculate the ultimate pressure from below of the slab base. We have to select the assume the size of base plate. So let LP is the length of plate, BP is the width of plate, or longer side of column or shorter side of column is D and B. So for equal projection, length of plate is equal to D minus B by 2 under root of D minus B by 2 whole square plus area required. So you have to find out the area required, and the area required you can find out it is above, that is, you know the bearing pressure, you know the load, so you can find out the area required. Area required is nothing but the load upon bearing strength. To divide, you can get area in square. Okay, so that from that you know the area required. And therefore you put this, and from this equation, you know the D the length of column, D is the width of column. You know, put all this value, you can find out the length of plate required. Then divide area divided by length of plate, you get the breadth of plate is required. Then you can find out the larger projection, LP minus D by 2, A, smaller projection B is equal to DP minus B by 2. Okay, where A and B are the larger and small projection respectively. So you know that this is your base plate, this is your base plate, this is your column. So here, uh, which one, the larger projection is called as A, which one is the smaller projection is called as B. It may be it may be A, it may be B, it depends on the projection. Okay, so A and B is the larger and smaller projection respectively. So based on that, you can find out the LP and BP length of plate and length of plate. Now the thickness of plate you can calculate because you know the larger projection. A is the larger projection. Okay, and B is the shorter or smaller projection. Okay, so you have provided the length LP and BP, breadth of plate, and this is nothing but this distance is Depth, this distance is width of your column, and this distance it may be A or B, depending on the larger or smaller projection. Putting all this value, the thickness of base plate is equal to 2.5 times of W is the bearing pressure you have to calculate, and it is calculated Pu upon 0.45 FCK. No, Pu upon FCK will give area. You will find out the pressure. Pu upon area provided. Pu upon area provided. It will give the intensity of pressure W, and put all this value, you can find out the thickness of base plate required. So this is how you can design the base plate. So this is the procedure to design a base plate or slab base. So first assume the suitable grade of your concrete. Depending upon the grade of concrete used, the bearing strength of concrete is determined. That is 0.45 FCK. This is the first step. So this is the maximum. 0.6 FCK is maximum. That is this WSL. We are not going for that. We are going for this only. Don't go for that. The area of slab base can find out. Area required. Area required you can calculate. That is nothing but Pu upon 0.45. Okay. That is bearing pressure. From then you get the area required. You know the column size. You know the column size. Okay. So L is equal to B is equal to under root of area required for initial sizing of the section. Otherwise, you can use this formula also to find out length of plate and breadth of plate. You find out this length of plate and then breadth of plate. You can find out from that empirical equation. You can use that empirical equation to find out the length of plate. The length of plate you can find out from that empirical equation, and breadth of plate you can find out area upon LP. Okay, so you will go into meter or in mm. Then length of length provided and breadth provided. Okay, that is LP and DP. Okay, okay, and then you can find out the area provided. AP is equal to nothing but length of plate into breadth of plate. You get the area in mm square. Okay, now you can find out the intensity of upward pressure W. This W is nothing but load, factor load upon area provided. You will get Newton per mm square this pressure W. Now put this value, because you know the larger projection A, you know the smaller projection B. Okay, put the values of A and B, you will get the thickness of plate required. But it should be noted that the thickness of plate required, if it is greater than TF, if it is greater than TF, then we provide TS by rounding up. Okay, round up to suitable size, suitable size, suitable size. अब समझ लो यहाँ पर आपका 8.99 आया, तो आप कितने mm का प्लेट 9 mm का प्लेट इस्तेमाल करेंगे क्या? 9 mm का प्लेट नहीं आता है. कितने mm का प्लेट आता है? 10 mm का. तो वो दो पर 10 mm. समझ में आ रहा है? तो जो मार्केट में अवेलेबल है उसके हिसाब से आप प्रोवाइड करेंगे. अदरवाइज ये नॉट प्रोवाइड. थिकनेस आपने मालूम कर लिया. थिकनेस मालूम करने के लिए मदद करने के बाद यू कैन प्रोवाइड अ होल्डिंग डाउन बोर्ड्स. Holding down boards you can provide, and that holding down boards hold the plate in position, and then design of connection will take place. We will see one example tomorrow. We will stop here up to the 9 steps of the slab base, and we will see how to solve the example tomorrow. So we will stop here. Thank you for joining. If you have any question about you ask, तो कोई क्वेश्चन है आपको आपको पूछना है तो आप पूछ सकते हैं अदरवाइज यहाँ पर मैं रुक जाता हूँ Anybody? I don't have any question.